This short video is about collimating a reflector telescope with a laser collimator. The one I have is a next generation laser collimator. I put it onto a 2-inch adapter to go straight into the telescope. There's 7 different light settings for brightness of the laser point. So the collimator goes into the eyepiece holder with the target facing back towards the primary mirror. I'm going to lock that in place like so. The idea of collimating is to align the secondary mirror with the primary mirror and the eyepiece holder for a camera or an eyepiece. So on the primary mirror you'll see we've got a little black circle which is the centre of the primary mirror. We've got 3 adjustment bolts on the bottom of the telescope, these being the primary mirror adjustment and these being the lock for the mirror to stop it moving. On the secondary mirror we've also got 3 Allen key bolts for adjusting the secondary mirror to get it in line. I've purposely put this a fair way out of collimation for this video, so I'll start by turning on my laser. So the laser dot is on. You need to see what we've got. As you can see, the dot is a fair way from the centre of the circle. Now the idea is to aim that dot bang on the centre of the little black circle, and at the same time having the dot disappear through the hole on the target inside the collimator. We can't actually see the dot at all at the moment. In fact, there's a dot on the wall over there. That's how far it is out. It's not even touching the secondary mirror, so not a problem. We'll start by taking this secondary mirror with an Allen key, insert it into one of the holes, loosen that off a fraction of a turn, go to another hole, tighten that and see what happens. And we see the dots moving towards the circle, so I went the right way. So I'm going to loosen that off a fraction more, not much, and I'm going to tighten that one again. So any more that way and it's not going to be correct, so I'm going to try another, loosen that a fraction, tighten this one a fraction, which is put it out a bit further, so loosen that one off a bit and tighten another one. Let's get it smack very close to centre, which will do for the moment. So now, glad to see no red dot on the wall anymore. We need to find our target and see where the laser is on our target. So it's missing the centre of the hole. What we've got to do is get that dot to disappear down the middle of that target. So by changing our collimation screws here and seeing which way, first I'm going to loosen off the locking nuts at a fraction. Now by looking at the dot, while I turn one collimating bolt, we'll see which way the dot moves. Actually moving towards the middle. Going slightly low. So go to another bolt and see what happens when I turn it. It brings it up and down the target. Next bolt. There we go, that went across the hole. So we're almost down the hole. Well, just in the dots completely disappeared. So it's aiming straight back from the secondary mirror, from the primary mirror to secondary mirror, straight down the laser dot hole. Now we can come back to the front and check down there again, and it's hard to get, but you can see, maybe see the laser dots a fraction out. It's probably acceptable, but being a bit of a perfectionist, I like to get it absolutely spot on. So I'm just going to adjust by loosening one, tightening another, till I get it exactly in the middle. This is quite fiddly, this end, knowing what screw does what, but it's just trial and error. That was on a bad move, that was almost into it. My dot seems to be fading. That's it, we're smack in the middle of the little black circle. So that's bang on there. Come back and check the collimation this way. You see, by doing that, we've put it out a fraction more. So loosen up that bolt, set locking bolts on the bottom, and twist the collimating bolts. You're actually twisting the mirror. There we go, it's gone. So at the moment, we're right on the dot, and there on the red, on the black circle, the laser pointer has disappeared down the hole. We're perfectly collimated. So now with these locking screws, I'm not going to lock them up, I'm just going to push them till they touch the primary mirror. So now they're locked in position. If I tighten them up too tight, I'm going to move the mirror. Checking again. There, we're spot on. So now with some heavier telescopes you can get flex in the tube, especially with the camera attached. So what I recommend is, if you're imaging one target all night, and especially if it's a low altitude target, is aim your scope roughly at your target and then collimate it in that position. I'll see if this has shifted when I turn the scope round. Knock that off and see if there we go. Look, you can see just by flipping the scope 180 degrees, the collimation's gone out. That's just the flex in a 200 1 meter telescope, 200 PDS. So that's proof that collimating it and then moving it may put your collimation out. So it's worth aiming your target, aiming at your target you want. There we go, dots disappeared. If you plan to do many targets in one night, which is quite often, I would suggest collimating the telescope in a neutral position, say park your home position or something like that. If you're on one target for the night, I would suggest collimating, aiming roughly at the target. Hope this has helped you in some way.